Hi, today I'll show you how you can use the action pattern in Zustand in a React Flow application and why I think it's better than the default store from the React Flow docs. I have a repository with several versions of the app. All of these versions do exactly the same thing. We have a flow with 2 nodes, a palette with a drag and drop function, and a custom function that allows manual creation of edges with buttons. I'll be comparing different approaches to state management in React Flow, so I'm assuming you already understand how state in React Flow works. There's the default version, which is built without an external store, versions based on a store without external actions, and finally, the version with external actions, which I'd like to show you. Let's look at the code. In each version, I have a folder containing flow and a nearby catalog folder with features. I will start with the external actions example, which is my preferred approach, and then compare it to the other implementations. The connectionMaker feature allows us to connect 2 nodes programmatically without dragging an edge. The button has 3 states: set source, cancel, or set target, which creates a connection. Let's examine the button component. In the connection button component, we have 3 active dependencies: selected node ID, the status of connectionMaker, and the current source node ID. What may surprise you is that we don't extract actions. They are imported directly from the store. That's one of the benefits. You don't need to import the hook just to call it in the component's body to get an action for use elsewhere. This is an unnecessary step. Importing actions directly like this also makes them easier to tree shake and code split, since they are independent and don't come from a dynamic store object. The second thing I appreciate about this setup is that you can easily jump to the function's definition. Let's check the implementation of setSourceNodeID. I can jump to that import directly in the editor. And I'm in. The implementation has 10 lines. We can see that this function also takes responsibility for changing the status when the source node is changed. How does that work with a regular store? Here, we have the store implemented using the regular pattern. The first thing we notice is that there are many more calls in the component body. Technically, I don't need to use shallow here, but if I were to take each definition from the store, it wouldn't be any less clunky, and it wouldn't change much in what I'm going to show. Let's check setSourceNodeID. I jump from the call to the extraction to use shallow, and finally end up in the store's type definition. The actual implementation is here, and I have to scroll to find it. It's a more complicated and worse experience. Look at the differences in implementation. We can check how the global store is implemented. The regular version has a mesh store API with store data. The type of the API is inferred from store type. This is how docs present this component. You can technically skip methods in type definition and do it like this, and it doesn't error here, but when you try to extract that method from the store, it will not have type. So at best, you can duplicate the type definition. Meanwhile, in the previous example, we have a nice, compact store showing data, with the onNode's change definition encapsulated in just 5 lines. Regarding the Zustand slices pattern, I could use them for both examples and merge the stores into one, but I would like to keep my features separate from the global store. Without an action pattern, it's easy to see the data kept in the global store and the API provided to modify it. All actions are written below. Both features, palette and connectionMaker, have temporary data that I would never want to save, such as the type of node currently being dragged or source of the connection. Zustand is also designed for smaller, independent states. Keeping a light/dark mode toggle inside the global store is not recommended. Additionally, if an inexperienced developer on your team uses the store directly in a hook without a cached selector, the component would re-render whenever any value in the store changes. With separate stores, that mistake would only affect the individual store. The impact of such a mistake is smaller, and it's easier to find the issue if it affects one of 5 small stores rather than one big store. Our feature stores are responsible for adding nodes and edges, and these actions modify the global store and clear temporary data. This isn't ideal, but we can achieve it while still providing a fully described store API below. Let's see how this works using the palette component as an example. In the regular version, the palette component extracts setDragType from the store and sets it in onDragStart. Next to it, we have a catalog with hooks, including one that returns onDrop. This hook is added above the ReactFlow component, and onDrop is passed directly as a prop. Let's take a closer look at onDrop. When we return to the hook, we see that it extracts DragType and addNode from the stores. These variables are used to build addNode onDrop, which is triggered by onDrop with the position taken from the event. This approach isn't inherently bad, but if someone forgets to clear setDragType, it could go unnoticed here and potentially cause issues elsewhere in the application. We can comment it to show an issue. How does it work in the noStoreAction pattern? The onDrop function is passed from the hook in the same way. The implementation doesn't call useStore. We have only one action here. The responsibility is quite clear. We have a store action defined in the store file, not in a hook. It updates another store and then clears the feature store. The implementation of addNode onDrop if dragged isn't hidden in the hook, but defined near the store. Having all store actions defined like this makes them much easier to manage. You could also just type onConnection and auto-import the function from your store. You don't need to call hooks or worry about their mutations. Your use callbacks end up with an empty dependency array. Those are the main benefits of using the noStoreActions pattern in Zustand. The data flow is cleaner, and we have fewer steps between them.